China's insane discovery is replacing concrete worldwide. There's a gray material sitting under your feet right now that the world uses more of than almost anything else on Earth. Only water beats it. For over 100 years, nobody found a real way around it. But engineers in China just built something that skips that gray material almost completely, and it's already going up in real buildings in a fraction of the time anyone thought possible. It's not some fake concept video. It's not decades away. It's happening right now, and almost nobody outside the construction world has heard about it yet. Stick around, because once you see how fast this thing gets built, you'll never look at a construction site the same way again. The world's favorite material. The material is concrete. Plain, gray, boring-looking concrete. It is in your sidewalk, your school, your driveway, and the bridge you drove over this morning without even noticing it. Engineers love it because it is cheap. It holds up skyscrapers. It can be poured into almost any shape. It does not rot like wood or rust like metal. For over 100 years, concrete has been the safe, easy choice for anyone building anything. But there is a dark side hiding behind all that convenience. Making cement, which is the glue that holds concrete together, means heating rock to super high heat. When that rock gets heated, it releases a huge amount of carbon dioxide straight from the rock itself. That is not because of dirty power plants or bad machines. It happens no matter how clean your electricity is. The pollution is baked right into the recipe. Now picture how much of this stuff the world actually uses. China alone poured more cement in just 2 years, between 2011 and 2013, than the United States used during the entire 20th century. Not in a decade, not in a generation. In 2 years. That is how deep the world's addiction to concrete really goes. And this is not slowing down. Cities keep growing. Roads keep stretching further. Bridges keep getting built over rivers that never had one before. Every single one of those projects leans on the same gray material, and every single one adds more of that trapped carbon pollution into the air. For years, scientists tried everything to fix this. They swapped in waste materials instead of cement. They tried new chemical mixes. They tried capturing the carbon at the factory before it escaped. Some of it helped a little. None of it changed the game. If you like stories about things hiding in plain sight, right under our noses for decades, hit subscribe now, because that is exactly the kind of story we dig up here. The fixes nobody saw coming until they were already happening. To understand how scientists finally cracked this, we need to rewind to the one question nobody had really asked before. Why nobody cracked it sooner? Here is the question almost every engineer skipped past for 100 years. What if the problem was never about the ingredients? What if it was about what happens the moment the wet concrete gets poured? Think about fresh concrete. Right after it gets mixed, it is not solid at all. It is a heavy, wet, sloppy paste full of water and trapped air bubbles, like a thick milkshake full of tiny hidden pockets of air. Normally, workers just pour it into a mold and let gravity do the rest. The water slowly seeps out on its own. The air bubbles mostly stay stuck inside. Then it hardens into whatever shape it was poured into, air pockets and all. Those trapped air pockets are the real villain of the whole story. Nearly every problem concrete ever has starts inside one of those tiny gaps. Cracks start there. Water sneaks in through there. Salt and chemicals travel through there until they reach the metal bars hidden inside, slowly rusting them from the inside out. In freezing weather, water trapped in those gaps turns to ice, expands, and splits the concrete apart from within. For 100 years, nobody tried hard enough to just squeeze those air pockets out before the concrete had a chance to harden around them. That is where this story turns. Here's where it gets interesting. The big squeeze. A team of scientists in China tried something almost embarrassingly simple. Instead of waiting for gravity to slowly settle the wet concrete, they squeezed it hard. While it was still soft and wet, they pressed it from the outside using serious mechanical force, similar to the crushing power inside a giant industrial press. What happened next is the whole reason this story matters. The extra water and trapped air had nowhere left to hide. They got forced right out. The tiny particles inside the mix got packed together so tightly that the concrete turned dense almost instantly, like the difference between a loose pile of sand and a tightly packed block of stone. Think of it like packing a suitcase. Most people just toss clothes in and shut the lid, leaving air pockets everywhere. Someone else presses down hard, squeezes all that trapped air out, and somehow fits twice as much inside using the exact same suitcase and the exact same clothes. Nothing new got added. The only thing that changed was the squeeze. In lab tests, this simple squeeze cut the tiny air gaps and holes inside the concrete by close to half. It also fixed the weakest point inside any piece of concrete, a microscopic zone where the glue meets the little rocks mixed into it. That zone is normally the first place a crack begins. Under this new squeezing method, that weak zone got dramatically tighter and stronger. The results were wild. Some tests showed the concrete became up to twice as strong. It resisted water, cracking, and freeze damage far better than normal concrete. And this method can also cut how much cement is needed in the mix by a quarter to half without losing any strength. Less cement means less of that trapped carbon pollution released in the first place. And here's the detail that makes this different from just another lab claim. This idea is not some rumor floating around online. It has already been filed as a real patent, checked over and approved by patent examiners who do not approve things lightly. Scientists from China, Australia, France, the UK, India, Italy, and Pakistan have all published their own research testing this same squeeze method, and they keep getting similar results. That is not one lucky lab. That is a pattern showing up again and again around the world. But strengthening the concrete we already use is only half of this story. The other half is even stranger because it asks a different question entirely. What if some buildings did not need nearly as much concrete at all? The material that isn't concrete or steel. While all this squeezing research was happening, a completely different company had already been quietly building something that skips heavy concrete almost entirely. It comes from a Chinese company called Broad Group, and it is called B-Core. Picture two thin sheets of stainless steel with a tight grid of small metal tubes packed between them, almost like the inside of a very tough waffle. That design is not random. It borrows directly from how airplane bodies are built, thin metal skins holding huge stress without adding huge weight. B-Core panels end up roughly 10 times lighter than a slab of concrete doing the same job, while still handling a similar amount of weight and pressure. This matters most in places where the ground shakes. Heavy buildings are dangerous in earthquakes because all that extra weight creates huge forces the structure has to survive. A lighter building has less weight throwing itself around, which makes it noticeably safer when the ground starts moving. Years ago, Broad Group proved just how fast this material could go together by building an entire 10-story apartment building in about 29 hours. Not 29 days, 29 hours. Workers were not rushing dangerously either. The panels are built to click together almost like oversized furniture, so a floor can go up in hours instead of weeks. The finished building even passed real safety standards, with plumbing, wiring, and windows already built in at the factory before it ever left for the site. Squeezing concrete tighter and skipping concrete altogether are two completely different tricks, but they are aimed at the exact same target, cutting how much carbon pollution and wasted material goes into every single building on Earth. And once you put the ideas side by side, it starts to look less like one lucky invention and more like the beginning of an actual shift. So where does all of this actually leave us? What happens next here is the honest part. Even a genuinely great idea does not flip the entire construction industry overnight. Building codes move painfully slowly, sometimes taking years or even decades to update, because a mistake in a building structure is not just expensive, it can cost lives. Every country that wants to use this squeezing method needs its own testing, its own approval process, and workers trained to run the equipment correctly. Most concrete factories on Earth do not currently own the machines needed to squeeze concrete this way, and building new ones costs real money. None of that changes what the actual lab results show. Researchers in multiple countries keep finding the same thing: stronger concrete, fewer cracks, and noticeably less cement needed to get there. That is not hype. That is data, repeated across different labs on different continents. Think about what that actually means for your own city. The same sidewalks, the same parking garages, the same bridge you cross every day could someday last longer, crack less, and cost the planet far less carbon to build in the first place. Nobody has to invent some brand new futuristic material to make that happen. The recipe already exists. It just has to get squeezed the right way. Concrete has barely changed in over 100 years, and it is the second most used material on the entire planet after water. So even a small shift in how the world makes it does not stay small for very long. Something we walk on, drive over, and live inside every single day is quietly starting to change, and most people have no idea it is even happening yet. If this changed the way you look at the ground under your feet, hit like, subscribe, and turn on notifications so you catch the next one. And I want to know what you think in the comments. If a fix this simple was hiding in plain sight for 100 years, what other everyday thing do you think is hiding its own obvious fix right now?